So hello everyone. Today I'm going to explain the topic heap sort. So in this topic we will study the concept of heap, a special kind of binary tree used primarily in implementing priority queues. We will learn about the two main types of heap, min heap and max heap along with their structure and properties. The topic also covers how heaps are represented in memory, particularly using arrays. When the concept of heap is understood, we will move on to the heap sorting, a sorting algorithm that uses the heap data structure to sort elements efficiently. And after the sorting, we'll include heap construction and element extraction properties. So what is a heap? A heap is a specialized binary tree based data structure that satisfies the heap property. It is a complete binary tree, which means all levels of the tree are fully filled, except possibly the last level, and last level is filled from left to right. The heap property varies depending on the type of heap. There are two types of heap, max heap and min heap. In max heap, the value of each parent node is greater than or equal to the value of its children. Whereas in min heap, the value of each parent node is less than or equal to the value of its children. So properties of heap. A heap follows certain important properties that define its structure and behavior. The properties are heap is a almost complete binary tree. A heap is always a almost complete binary tree, meaning all levels are completely filled except possibly the last level, which is filled from left to right. This ensures that heap has logarithmic height, making operations efficient. The next heap order property. This property depends on the type of heap. In max heap, every parent node has a value greater than or equal to its children. In min heap, every parent node has a value less than or equal to its children. So here are some more properties. Heap height. The height of a heap with n elements is this O log n. This is because it is a complete binary tree and each level doubles the number of nodes. The array representation of a heap can be efficiently stored in an array without using pointers. For node at the root index, a root index is at zeroth index. Root node is at zeroth index, whereas left child is at index to I plus 1 and right child is at index to I plus 2 and parent is at index I minus 1 by 2. So insertion and deletion. Insertion of new elements takes big O of log n time due to upward heapification, whereas deletion also takes big O of log n time due to downward heapification. So this is the re-representation of a heap. At zeroth index, the root element is present, and at first index, the left child of the root element is present, and at second index, the right child of the element is present. If we want to find the left child of the node 19, then we have to use the formula 2i plus 1, which is 2 into 1 plus 2 into 1 plus 1, that is 3. It will be 17. And if you want to find the right child of the node 19, 2i plus 2, it will be 4. So the 3 is the value. In this way, we will find out the values. Next, heap types. Heaps can be used to sort data in both ascending and descending order by choosing the appropriate type of heap. Min heap, max heap. Min heap for descending order and max heap for ascending order. So min heap. A min heap is a type of binary heap where the value of the parent node is always less than or equal to the value of its child node. This means the smallest element is always at the root. It maintains a complete binary tree structure which ensures that the tree is filled from left to right. Min heaps are commonly used in priority queues, Dijkstra's algorithm, heap sort, when sorting in ascending order. So properties of a min heap. Heap order property. The value of each node is less than or equal to the value of its children, and this ensures that minimum element is always located at the root. So it is a complete binary tree. A min heap is a complete binary tree. So all levels are completely filled except the last, which is filled from left to right. And efficient operation. The min heap has for time complexity big O of log n time because they may require moving elements up or down the tree to restore the heap property. So array representation, it is same as the normal heap, left child of node at index to I plus 1 and right child of Right child at index 2I plus 2 and parent I minus 1 by 2. Root node contains the minimum element. Since the heap property maintains smaller values at the top, the smallest value in the entire heap is always at the root, that is index 0. So this is the representation of the min heap. So first index, it is 1 and left child it is 2, right child it is 3. In this way it is represented. For node at I, left child will be 2I and right child will be 2I plus 1 and parent will be at 3 by 2. So there is second type of heap, max heap. A max heap is a type of binary heap in which the value of parent node is always greater than or equal to the value of its child node. In other words, the largest element will be the root. Like all heaps, max heap is a complete binary tree, meaning it is filled level by level from left to right. Max heaps are especially useful when you need quick access to largest elements, such as priority queues, heap sort, and certain scheduling algorithms. So, properties of max heap. Heap order property. In max heap, the value of each node is greater than or equal to the value of children. This ensures the maximum element is located at the root of the heap. Complete binary. A max heap maintains the complete binary tree structure. All levels are fully filled except possibly the last level, which is filled from left to right. Efficient operation, insertion and deletion takes big O log n time. After any change, the heap is restored by performing heapify operations. So array representation, left child of node at index I is 2I plus 1 and right child is 2I plus 2. Parent is at the index I minus 1 by 2 and root node contains the maximum element. The largest value in a heap is always found at the root, which is at index 0 in array representation. So this is the maximum heap where the root element contains the maximum element, that is 100. So sorting of a heap is done in two ways. Construction of a heap, deletion of max heap. So let us consider this example. So in this 10 is the largest element which is at the bottom of the root the tree. So we have to bring this element to the top, that is the root index. So before that, check whether 4, 9, 3 are in correct place or not. And so those are in correct place because 9 is greater than 4 and 3. Now next, check 4, 8, 10. 4 is lesser than 10, so swap 4 and 10. So 10 comes at the index 1, and whereas 4 goes at the index 4. Now check the right child. So 5 is greater than 3 and 3 is lesser than 5. So swap both the elements. 5 will be at second index and 3 will be at sixth index. So after swapping those elements, we got two smaller valid max heaps. Those are this one and this one. We got two max heap. Now check these three elements, that is 10, 9, and 5. Mm, 9 is smaller than 10. So 10 should be at zeroth index and 9 should be at one index. So swap these both. So swap 10 and 9. So we get the final binary tree. So after that, start deleting the max elements from this. So after bringing the 10 at the root index, now delete the root index one by one. So bring 3 to the root and delete 10 from the tree. So in this way, we'll swap 10 and 3. 10 goes out of the tree and then heapify the table, sorry, heapify the tree. So 3 is less than 9, so 3 and 9 get swapped. And next, the 3 and 8, 3 is less than 8, so 3 and 8 get swapped. After that, swap 9 and 2, bring 9 out of the tree. After that, once again heapify, continue the step. Heapify 2 and 8, 2 is less than 8, so swap 2 and 8. Next, check 2 and 4, 2 is less than 4, so swap both. Now this is in correct. Now this tree is in correct order. Then after that, swap 2 and 8. Bring 2 to the root and 8 out of the tree. So after that, once again check whether it is this follows heap property or not. Thank you.